Okay, everybody, now that we know what a monomial is, we're actually going to get into the more meaty part of our standard. So if you remember in the first video, I said there were 4 standards we were going to address during this chapter. And now we're really going to start hitting hard on this first one, which is I can identify and interpret parts of a polynomial expression. So first things first is we know what a monomial is. It's an algebraic expression with just one term. So now we're going to look at what a polynomial is. And a polynomial is an algebraic expression with more than one term. Okay, so it could have 2 terms, 3 terms, 4 terms. Okay, and eventually we're going to identify what a term is, and a term are the things that are kind of separated by the pluses or minuses. So you're going to have like a bunch or a grouping of numbers and letters, and then a plus or a minus, and then a bunch or a grouping of some numbers and letters. So specifically when we're talking about a polynomial, we have what's called a binomial, and a binomial is a polynomial with 2 terms. Okay, so one of the examples we dealt with before was 5 plus x. That has 2 terms. It has the 5, it has the x, and they're separated by a plus or a minus. Another example of a binomial would be like 7x squared minus 4x. Okay, so you have the 7x squared, then you have a minus sign, and then you have the 4x. That's a binomial, so it has 2 terms. A trinomial, think of a tricycle, is a polynomial with 3 terms. Kind of like a tricycle has 3 wheels. So this example would be like 5x cubed minus 7x squared plus 1. Okay, so the 5x cubed is 1 term, the 7x squared is another term, and the 1 is a 3rd term. Those are your 3 terms, and they're separated by the pluses or minuses. So that's a trinomial. Now, the degree of a polynomial is the largest exponent. Okay, and we could get a little more complicated than that, but that's about with what I'm going to go with here, because polynomials are a little bit different than your monomials. If it's a monomial, you're just going to start adding whatever you've got. Usually when we're talking about polynomials, you're only dealing with one variable, and you're going to pick the largest one. So if you go back to this example I have on your trinomial, the largest exponent is 5x to the 3rd. Then you have an x squared, but that's not the largest. Then you have a 1, which doesn't even have an exponent. The largest one is 3, so the degree would be 3. If you're working with your binomial example here, I've got a 7x squared, and then I've got a 4x. So x squared has a degree of 2. 4x has a degree of 1. The largest is the 2, so the degree would be 2. We'll go into that more. Standard form is you write your polynomial from largest to smallest exponent. So if something has an exponent of 3, you put that first. If something has an exponent of 2, you put that second. If something has an exponent of 0, you put that last. And again, that will make more sense once we do it. And then last but not least is your leading coefficient. It is the number in front of largest degree. Okay, so you have to identify what the degree is. Of course, that's going to be the largest one, and then you just look at the number in front. Examples. Or actually, before we get to examples, we're going to look at some naming. Okay, so this is how we name our polynomials. We give them specific names. I don't know if I spelled that right, but naming. Okay, if your polynomial has a degree of 0, you're going to call it a constant. If your polynomial has a degree of 1, you're going to call it linear. And at this point in time, I want you thinking about a linear graph. So last year when you graph linear equations, it's y equals mx plus b, which is y equals x. That x has a degree of 1 on it, hence linear. If it has a degree of 2, we call it quadratic. And these are the type of graphs you're going to be graphing this year, y equals x squared. They're going to look quadratic. If it has a degree of 3, you're going to call it cubic. And then if it has a degree of 4 or more, you just use the number. Okay, so for example, you just say 4th degree, dot, 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 5th degree, dot, 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 6th degree, dot, 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 etc. If it's got a 7, 7th degree. If it's got a 100, 100th degree. You just call it the number. We don't have special names. Okay, terms. If it has 0 terms, it doesn't exist. Okay, if there's nothing there, there's nothing there. We don't have a name for that. If it has 1 term, we already went over this. That's a monomial. If it has 2 terms, we already went over this. That's a binomial. Think about a bicycle. It has 2 wheels. If it has 3 terms, think about a tricycle. That's a trinomial. And if it has 4 or more, 4 terms, 5 terms, 6 terms, etc., that we just give it the generic polynomial, keeping in mind that poly means many, so many terms. Okay, now we're going to look at our examples. Write each polynomial in standard form, then classify it by the degree and number of terms. So letter A, we have to write it in standard form. Now, standard form means you take your biggest exponent and you write it first, and then your next biggest, and then your next biggest, etc. So I'm looking at that x cubed. X cubed has the biggest exponent on it. The other thing I'm looking at is that it's got a negative in front of it. So I'm going to take my x cubed and I'm going to write negative x cubed. That's my first term. And then my x, my 15x, has a degree of 1. So that's a positive 15x. And then last but not least, plus 3. That right there is standard form. Your exponents go 3, 1, none. So they go from the biggest exponent down to the smallest. Now, we have to identify it or name it by the degree first and then the number of terms. Keep in mind that the degree always has to come first. If you flip that and name it by the number of terms and then the degree, you're wrong. Okay? So, the degree is going to be 3 because that is my biggest, okay? Not like a monomial, you don't add these things to anything else, okay? So no adding, it's just the biggest one. So if I have a degree of 3 and I look back at my chart, degree of 3, I'm going to call a cubic. So this is a cubic. And then how many terms? Well, there's 1, 2, 3 terms. Those are separated by the pluses and the minus. So if I look back at my chart again, trinomial. Okay, now I know it didn't ask for it, but just to go over this idea of leading coefficient. Leading coefficient is the number in front of the leading term. Well, once you write this thing in standard form, here's your leading term. The number in front of that, do you notice that negative? Okay, there's actually a number there, you just can't see it. Your leading coefficient would be negative 1. Okay, next example, letter B. 4 minus 9z. First of all, standard form. So we have to look at the degrees. 4 doesn't even have a variable on it. It doesn't have a degree. So the 9z is going to come first, which is negative 9z, and then a positive 4. That is your standard form. If I name it by the degree right here would be this guy. I can't see anything, but there's a 1 hiding. So the degree is a 1. If the degree is a 1, I'd look back at my chart. That would be a linear. And then by number of terms. There are 1, 2 terms, so it is a linear binomial. And again, I know it doesn't ask for it, but leading coefficient is the number in front of the leading term. So if negative 9z is my leading term, then my leading coefficient is negative 9. Letter C, negative 3z to the fourth. First of all, we have to write it in standard form. This only has one term, so guess what? It's already in standard form. That's great. Okay, so standard form is done. Now we have to do degree and number of terms. The degree, right there, that's a 4. So if you look back at your chart, we don't have a special name for 4, so we're just going to call it a fourth degree. And then number of terms, there's only one, so monomial. And then once again, I know it doesn't ask for it, but if I wanted the leading coefficient is the number in front. The leading coefficient would be negative 3. Letter D, 5. Standard form, it's a 5. It's already in standard form. We don't have to do anything with it. Degree, so the degree is the exponent on the variable. There's no variable, so the degree is 0. Okay, look back at your chart. If we have a degree of 0, this is called a constant. The reason it's called a constant is because it's always 5. 5 is a constant number, so it doesn't change. A variable can change. A variable can be anything I want it to be, but 5 is just 5. Number of terms, 1. So that is a monomial. So constant binomial, and then if we were to do it, leading coefficient is the number in front. It's the leading number. We don't have a variable, but that's okay. It's still 5. Leading coefficient would just be 5. Okay, last but not least, letter E. Okay, standard form, we have to put the biggest exponent first. I'm looking at that q to the 5th. It is a positive, so we're going to have q to the 5th, positive 8q. That is your standard form. Name it by degree and number of terms. So degree, biggest one. Again, if it's not a monomial, we don't add, okay? Don't add anything, it's just 5. So 5th degree, and then number of terms, 1, 2, binomial. And then if I wanted the leading coefficient, it's the number in front of the largest one. So the leading coefficient, I don't see anything there, but there's actually a 1 hiding. It's implied. So the leading coefficient here would be 1.